Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 9th grade topic, multiplying polynomials. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we did today, or even on homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video is going to have 3 parts. So leave a like, smash the subscribe button, and let's get started. When multiplying polynomials, although it can get pretty tedious depending on how long your polynomials are, the overall process is actually rather simple. It just relies on you being able to distribute, just like you did in this case here. So let's say you had 7 times x plus 2. And I told you to multiply this constant by this polynomial, or in this case, binomial. You would distribute that 7 to both of these elements of the polynomial, resulting in 7x plus 14. When multiplying polynomials, you're actually going to do the same thing. So instead of 7 times x plus 2, let's say we have x plus 3 times x plus 2. Well, if you did the same exact thing, treat this like you would your 7, and then distribute it to each element. That results in, now it's very important that you keep note of your signs. Don't lose any signs when you're multiplying. Notice these are both positive, so the positive is still there. Now we've transformed something that looked a little bit more complicated to something that looks a little simpler, and you have 2 of them. And if you can't necessarily see what to do next because it's written this way, remember, when you're multiplying, it doesn't really matter in which order you multiply. So x plus 3 times x can also be written as x times x plus 3. Likewise, your x plus 3 times 2, you can rewrite that as 2 times x plus 3. Now, you distribute like you did previously. This x goes to each element. This 2 goes to each element. And you're going to get, now that everything has been distributed, all you have to do is combine your like terms. We have an x squared, we have some x's, and we have a constant. These are the only things that we can combine, so when we do that, we get, and this is how you would go about multiplying your polynomials to get something that looks a little bit like this. But notice, this can get pretty tedious, but it's not all that difficult. It's just distributing. If you can distribute, you can do this. And like I just said, this can get pretty tedious if your polynomials are very, very large. However, if you are fortunate enough to deal with binomials like this, you actually have a shortcut, a little pattern that you can take advantage of. So let's say, instead of it looking like this, I rewrote it like this. X times x plus 3 times x plus 2 times x plus 2 times 3. Do you see a pattern with this? This is the same thing as this, but I just wrote it out. I didn't combine them, letting you see where things are multiplied. Do you see a pattern that you can take advantage of? Let's look at the elements in each pair and see which ones are going to be unique. So we have x, we have 3 and another x, but we already have an x there. We have 2 and another x, but we already have x, and we have 2 and 3. So we have x, 3, and 2. Where else have you seen these elements? Well, if you look back up here, you have x, 3, and 2. So x, 3, and 2 show up here, and x, 3, and 2 show up here. There's a pattern here that when you have binomials being multiplied to each other, you can actually take advantage of, and it's a whole method that we call the FOIL method. So let's jump into the FOIL method and see how we can possibly save a few steps when you're dealing with polynomials being multiplied together, except they're shorter. So FOIL is pretty much a shortcut when you have shorter polynomials being multiplied together, but more specifically, you have 2 binomials. So when you have 2 binomials, you can use this thing called the FOIL method. Now, what does FOIL stand for? First, outer, inner, last. And this is really just a roadmap on how you're going to be multiplying your different elements of your binomials. So instead of what we did in the previous section, in which you took this whole thing and multiplied by each element, you're going to look at the elements of your first binomial, and you're going to multiply them by the elements of your second binomial. So following FOIL, we're going to look at the first elements in both sets and multiply those to each other. So first means that we're going to multiply this x and that x. So you get an x squared. Outer means you look at the outer elements. So this is your outer element for this one, and this is your outer element for this one. These are the outside. So you're going to multiply that first outer, and you're going to keep the sign. It's very important that you keep the sign. Sign is very, very important. So I'll move this down. That's x squared. This was an x times that, so we're going to have plus 2x. And whenever we're doing this, it's multiplication. So next we have inner. Well, if this was your outer, this should be your inner. This is your inner. So that's going to be plus 3x. Then you have your last. This is the last term in this binomial. This is the last term in this binomial. So you're going to multiply those together, which gives you that. Now you once again combine your like terms. You have x squared plus 5x plus 6. And if you recall, that's what we got in our previous section. Doing it the longer way, we got the same exact thing. So when you're blessed enough to have two binomials that you're multiplying, you can actually use FOIL, and that can shorten things up a bit. Instead of having to distribute everything, like all of this at once to each of these elements, and then having to do all the other distributions later, you can save some time using your FOIL method. Now you may be wondering, are there any shortcuts for when you're multiplying two bigger polynomials? Can you use FOIL for that? Unfortunately, you can't use FOIL for multiplying bigger polynomials, but you can expand on the concept of what you're doing in FOIL for bigger polynomials. Let's jump in and see how. Let's say we have bigger polynomials that we're trying to multiply, and we want to use something like FOIL, but we understand that they're not binomials, so we can't use FOIL. Can we still use the concept behind what we did in FOIL? Instead of having to multiply all of this by each element and then having to break down the distribution that way, can we do something else to kind of save a few steps? Well, let's break down what the process was for your FOIL. So you have first, outer, inner, last. But what is this actually doing? Notice your x goes to two things, your 2 goes to two things. So all it's really doing is taking each element in here and multiplying it by each element in here. That's all FOIL is. So although you can't necessarily have a nice, easy way of foiling, you can still do that distribution, and you can possibly save a few steps doing so. So let's do that with our expanded multiplication here. We have two trinomials here, and we want to multiply them. Let's skip a few steps and multiply each element in here by each element in here. So when doing so, let's take our time, because you don't want to get confused. You don't want to miss anything. We're going to take our time and do one at a time. We're going to one of these by all of these, one of these by all of these, and so forth. So let's start with x squared. So we're going to have x squared times x squared. Take into account your signs. This is going to be x squared times 2x, but it's going to be a minus. Or you can say this is plus, so you don't get confused, and you keep your negative with your 2x. However you want to do it, don't drop your negative. Then you're going to have your x squared times your negative 1. Now you've accounted for all of your x squareds that you need to put. Let's move on to this x. Notice the sign. You have plus x times x squared, doing the same thing, plus x times negative 2x plus x times negative 1. And continuing that, we're now moving on to this. And now it says a minus 3. Your sign is very important. So you can either plus a negative 3, or you can minus 3 times everything else. So I would just say, just so you can see where all the negatives came from, I'm going to just add everything but keep the parentheses. So it's going to be negative 3 times your x squared is going to be plus a negative 3 times a negative 2x plus a negative 3 times a negative 1. Now each element in here has been multiplied by every element in here. So let's simplify this a little bit to see what our almost final result will be. This x squared times x squared gives you an x to the fourth. You have a negative 2x times x squared gives you a negative 2x cubed. You have x squared times negative 1 gives you a negative x squared. X times x squared gives you an x cubed. Negative 2x times x gives you a negative 2x squared. X times negative 1 gives you a negative x. You have negative 3 times x squared gives you a negative 3x squared. You have negative 3 times negative 2x gives you a positive 6x. And you have negative 3 times negative 1, which gives you a positive 3. It's always very good to check your work. Now that we've simplified this a bit, we can simplify some more by combining our like terms. So we only have one x to the fourth. However, we have how many x cubes? We have x cubed there. So we have one x to the fourth. So we can actually put that down here. We have only one of them. We have an x cubed here. We have an x cubed here. And that's it. So let's combine those and we're going to get a negative x cubed, right? So that's taking that into account. Now how many x squareds? We have that one, we have that one, we have that one. So we have a negative x squared, that's a negative 2x squared, and this is a negative 3x squared. So negative x squared minus a negative 2x squared minus a negative 3x squared. So we have a bunch of minuses here. So this gives us a negative 6x squared. So we've handled the x squareds. Now let's move on to x's. Do we have any x's? Yes, we have that x and we have that x. Combine those, you get a positive 5x. Now we've handled our x's. Do we have any constants? Yes. We add that. Now we have everything accounted for. Our x to the fourth, our x cubed, only two of them. We have our x squareds. We have our x's. And we have our constant. Everything is accounted for. We've simplified this as much as we can. There are no more like terms. And we have effectively multiplied our two polynomials. And although this doesn't look like you saved a lot of steps, remember, like I said, this can get pretty tedious depending on how long or big your polynomials are. These are just two trinomials. This can get even larger. And if you save on even one step of writing all that stuff out, you save a lot of writing. So I hope you're able to follow along with this video and hope you now see that it's pretty simple when you need to multiply your polynomials. Just be prepared to have a little bit more writing depending on how long they are. However, if you have any questions about what we saw today or even your own homework, feel free to either put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, hit that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework and look forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Me Sempai.